I was thinking about uncertainty. It makes me uncomfortable. It stresses me out. It's easier to believe that things are certain than to deal with the void of the unknown. Uncertainty. These meters have a reputation for being accurate. And for extra money, you can even guarantee their accuracy by having them calibrated in a lab by someone that can be trusted. This one here, it's cheap, but it has a 6,000 count readout. Does that mean that we can trust it to be accurate? Steven said the truck had enough gas. The gas gauge said the truck had enough gas. The truck ran out of gas. That gas gauge was not accurate. Steven can't be trusted. Just because your meter points at something doesn't mean you're pointing at something that makes sense, even if Steven says it does. All meters, even when they're calibrated, have uncertainty. Say your Simpson meter measures a voltage. This is the voltage that the needle on the meter is pointing to. This does not mean the actual voltage, the voltage present when no one is looking, is the voltage being pointed to on the meter. Instead, when you see a value on your meter, all you really know is that your actual voltage lies within a range of voltages around the measured value. Humans do this naturally. Say I measured this battery with a ruler. I wouldn't say the battery is 2.397 inches based on what I see using this ruler. I'd say it's between 2.25 and 2.5 inches long. See? I used a range, like normal people do. You could do better with a micrometer, but not too much better with a ruler. Humans know this. If you're going to function as an engineer, you need to know your equipment. And for something like a calibrated Simpson meter, you are usually presented with a range of uncertainty looking something like this. That is, your actual voltage is equal to your measured voltage, or that voltage that your meter is pointing to, plus or minus some uncertainty. Do you think Steven knows this? Actually, you can find the range of accuracy for your calibrated Simpson meter within the Simpson Operator's Manual. Here, this is the range of uncertainty I was just talking about. For DC voltage and most DC current ranges, the actual value measured is within 2% of full scale. I have a really cool trick to show you how to use that information. The secret to knowing how to correctly read your meter is to know that this arc on the meter sweeps out exactly 100 degrees. And that each of these ticks divides the 100-degree arc into 2-degree arcs. Now, what does 2% of full scale mean with regard to this 100-degree arc? Well, 2% of 100 degrees is 2 degrees, which means if you take a DC measurement, all you have to do is observe the range of values between one tick before and one tick after the location your needle is pointing. And this works for any range selected on the Simpson meter. So suppose I set the meter to the 50 volt range and the needle points here. The correct way to report this measurement is to say that your voltage on your calibrated Simpson meter is between 24 and 26 volts. Some further care is required when reporting values provided by your Simpson meter. There is more thinking involved. What gets me all the time is that these meters have a low input impedance. If you want more of a description about this, I made a video linked below. Make sure that whatever you are measuring has an impedance much lower than the internal impedance of the meter. These meters have an impedance of 20k ohms per volt. So for the 50 volt range, the internal impedance of the meter is 1 mega ohm. Ideally, and if you want the uncertainty to be as simple as reading plus or minus 1 tick, you should try to make sure the circuit you're measuring in this 50 volt range has an impedance at least 100 times lower than 1 mega ohm. So in this case, for the 50 volt range, you would only want to measure things on the 10 kilo ohm range. Now, and I can't stress this enough, the analysis I've talked about up till now relies completely on trust, on whether or not you believe Mr. Simpson to be a liar. You have to have confidence in him when he says the accuracy of this meter is within 2% of full scale. Mr. Simpson is not a liar. So I believe that the voltage I'm reading here is somewhere between 24 and 26 volts. Steven is a liar, so it doesn't matter what the uncertainty of the gauge is. If Steven vouches for it, it's not good.